let's say this is the ground, and we have a ball, favorite yellow ball again, that is at a height of let's say this height h is 1 meter above the ground. Okay, and the mass of the ball is m. So if I drop the ball falls faster and faster. And when it hits the ground, or just before it hits the ground, it has kinetic energy. Be moving at a velocity, say v or u. So it had, let's say it was dropped from rest. So we know that the gain in the kinetic energy, the Ke down here, would be equal to the Pe when the ball was there, the potential energy. So the potential energy when the ball was here, as it falls, the potential energy decreases to 0 and gets converted to kinetic energy, which increases as it falls. Okay, so after falling the height h, the potential energy will be all, right? The potential energy due to this height h will be all converted to the kinetic energy. So if this kinetic energy is half mu squared, and that potential energy was mgh, so these two would be equal. Those two would be equal. That's fine. Okay, so we kind of understand this now. But let's go back to here and think about what happens now if, instead of this being the ground, what if this is the tabletop? Okay, maybe not the tabletop. Let me do it this way. What if right, this is still the ground, but a bit further on, okay, what if there is a step? Okay, there is a step, and then this, after the step, the ground is lower by, maybe 0.5 meters, or maybe 0.2 meters. Okay, so there is a step down here, and the ground is lower. Now, what if I move the ball over here just horizontally, keeping the same level until here? What if I drop the ball there? What's its potential energy? What happens when it hits the ground? Right, when it falls down here, what is the kinetic energy? Surely it can't be mgh, because the h is the h above this ground, okay, which is higher than that ground. Surely I must take a new h, right? I must take a new h. This height there will be h1. I must take my potential energy here as mgh1 instead of the mgh when it was there. So it looks like I have to keep changing my, I have to change my height or change my h if I move to a ground that is lower. Alright, if I take a step down to a lower ground, I have to change my height. Okay, so that works if you're just, as long as we refer to whatever ground we are on. But it is often also more useful to refer to a fixed level as the reference for the height, meaning that even if I change to a ground that has a different level, it would still be useful if I refer to just one fixed level for height. That means that instead of changing height to h1, there is another way to do this. Let's retract that. So what I'm going to do is I'm going to use this as my reference level, reference ground level. Okay, and I want to find out what happens. Say I want to calculate the kinetic energy when I drop the ball from this same level, the same height above the ground, h. But I want to find out what happens when it falls down to a lower ground. That's meters. Falls down to a lower ground. I want to find the kinetic energy. Yeah. Okay. How can I do that? I can't use mgh anymore with this h. So how can I do that? Now the way to do it is this. Okay, the way to do it is to think about positive and negative directions for h. So think of the h like a displacement. So I have, let's say, if I choose up as positive and down as negative, then for when the ball is at the height of 1 meter above this reference level, I'll call this height plus 1 meter. And when the ball is at 0.2 meters below this reference level, I'll call this height minus, I'll call the height of this ball, which is below the reference level, I'll call it minus 0.2 meters. Okay, so that's the first step. We define a positive and negative direction, and we use positive and negative signs to represent heights by comparing the level of the ball with the reference level. Okay, that's step number 1. Step number 2, then if I want to find the kinetic energy when the ball, say, drops from there to there, drops from one height to another, what I can do is I would do it by finding the difference in the potential energy. The potential energy defined by PE, potential energy is equal to mgh. So I would continue to use this formula. But I would but my h can be would be measured measured from this reference level. So to find the kinetic energy when the ball moves from one height to another, then the formula is to find the change, right? The way to do that is to find the change, or rather, in this case, right? Okay, I'll find the decrease. Find the decrease in potential energy. Okay, because when there's decrease in the potential energy, the decrease is changed into kinetic energy. And we find the decrease in potential energy like that. This is how we can do it. We take the initial potential energy. If I call this height, say h1, and I call that height h2. So all I need is to take the initial potential energy mgh1 and minus the final potential energy when it's at this height h2, so minus mgh2. Now if I do that, what I have here is that whatever the weight mg is, I can factor it out, mg, and then I have h1 minus h2, but h1 minus h2 is the 1 meter there, minus h2, which is minus 0.2, so minus 0.2, so minus and minus, minus here and minus here becomes plus, so I end up with mg times 1.2, and this now, this 1.2 is actually the overall height when the ball falls from there to there. So by using this plus and minus sign method and this difference in decrease in PE method, I end up getting the correct change, the correct potential energy as if I use the new ground as the point where I measure the height from. So what this means is that we now have a way of defining the potential energy, and this is how I can express it. You can express this by saying that the potential energy, right, is the work done to move a body from a reference point to, let's see, now we have 2 points to talk about. We have this position and this reference point. Potential energy is work done to move a body from a reference point to its position. Okay. Right, and that's one way to describe it. So if I move this ball from this reference point to its position, I have to do work against the gravity. Okay, and the work done is this force, the force times the distance moved, mgh, which is correct. That's the potential energy. So we can define this as the potential energy as this, and the important point here is that I don't have to think of potential energy to refer to a particular ground level. I can think of just any reference point, or in this case a reference ground level. Okay, and even if I go to another ground, I can continue to make use of a fixed ground level, and in my new ground I can continue to use this mgh as my potential energy, and whenever I need to calculate say the increase or the kinetic energy gain when an object falls, all I need is to use the same formula mgh and calculate this potential energy at the two levels, the starting level, the ball, and the final level. Find the decrease in potential energy, and that would give me the gain in the potential energy, in the kinetic energy.